So in this mini module, we're going to talk about the concept of tack time. And tack time is the rate of production or how fast a part needs to be made in order to be able to keep up with customer demand. Takt is the German word for musical meter or the speed that the music needs to be played so that everyone is in sync. The actual definition of tack time is the time available in a day divided by the number of parts made in a day. So we are now going to go through some examples of tack time, but before we do that, we're going to talk a little bit about some terminology and then also some assumptions. So terminology wise, seconds are going to be indicated as the quotation symbol, and then minutes will be indicated as the apostrophe symbol. Now, as far as assumptions though, we're going to assume that a typical shift is 8 hours long. 8 hours times 60 minutes in an hour is equal to 480 minutes. So at the end of the 480, in order to indicate minutes, we're going to use the apostrophe symbol. So we'll put that right after our 480 in this example. Now, our 480 minutes times 60 seconds in a minute, if we multiply that, we come up with 28,800 seconds. So we're now going to indicate the seconds by putting the quotation symbol at the end of 28,800. So now we've shown how to represent minutes, we've shown how to represent seconds. Our other assumption is that our work month, typically when we do these calculations, is 20 days. So the first part of our equation for tack time is time available. Time available is equal to the minutes in the shift minus breaks. So for our example, we're going to assume that we have an 8-hour shift with the 30-minute lunch and two 10-minute breaks. So the minutes in a shift is going to be equal to 8 hours times 60 minutes, which is equal to 480 minutes. Now our breaks are 30 minutes for lunch, two 10-minute breaks, so that adds up to 50 minutes. So our available time is equal to the 480 minutes in a shift minus the 50 minutes for breaks, which comes up with 430 minutes. If we now take the 430 minutes and multiply that times 60 seconds, we come up with 25,800 seconds in a shift. So for our first example of tack time, we're going to assume an 8-hour shift with a 30-minute lunch and two 10-minute breaks. So as we showed earlier, time available for an 8-hour shift is 25,800 seconds. Customer demand is 5,000 pieces per month in this example. So in that case, our daily demand is going to be equal to 5,000 pieces per month divided by 20 days in a month, and that's going to come out to 250 pieces per day. Our tack time in this case, again, remember it's time available divided by daily demand, so that's going to be 25,800 seconds divided by 200 pieces, and that's going to come out to 103.2 seconds. So we're always going to use a whole number when we discuss tack time, and we're going to round down, and that's going to be because we want to make sure that we can meet the demand that we have for the day. So we're going to, in this case, round down to 103 seconds. So we're going to now go through some scenarios, okay? So for this example, if cycle time is less than 90 seconds, can we meet customer demand? In this case, tack time, which is 103 seconds, is greater than cycle time. So customer demand can be met. But let's go through another scenario of what happens if cycle time is 120 seconds. In this case, tack time, which is 103 seconds, is less than the cycle time of 120 seconds, so customer demand cannot be met without overtime or additional personnel being assigned. So you can see, what Tack Time allows you to do is it allows you to see whether your production cell or whatever process you're doing can meet the pace of customer demand. We're going to go through another scenario. What happens if cycle time is 200 seconds? Actually, if cycle time was 200 seconds, based on we saw the tack time is 103 seconds, we would look at considering 2 shifts. Example 2 we're going to look at now is what happens if we add a shift. So in this case, we'll assume we have 2 8-hour shifts, again with 30-minute lunch and 2 10-minute breaks. So the time available is going to be equal to a shift's worth of work is 25,800 seconds times 2 shifts. That's going to be equal to 51,600 seconds. Again, customer demand is 5,000 pieces per month. So daily demand is equal to the 5,000 pieces per month divided by 20 days, and that's going to be equal to 250 pieces per day. Tack time in this case, though, with the 2 shifts is equal to 51,600 seconds divided by the 250 pieces, and we come out to 206.4 seconds. And again, if we round down, we come out to 206 seconds. And again, remember, tack time is equal to the available time divided by daily demand. So in this example, what happens if cycle time is now 200 seconds? If cycle time is 200 seconds, our tack time, which is 206 seconds, is greater than our cycle time of 200 seconds, so customer demand can be met. We're now going to talk about the concept of managed tack time. And managed tack time, we use that when sometimes there's an expected lost time in a shift, which takes away from the available time. So the calculation of managed tack time allows us to account for that. So managed tack time is equal to the available time minus the expected lost time divided by the number of parts made in a day. So in example 3, we're going to go through an example of managed tack time. A production cell has 3 parts made in the cell, and it changes over once a day to produce one of the parts. So in this case, in this example, the changeover time will be 60 minutes, and 2 shifts are run with a 30-minute lunch and 2 10-minute breaks. We'll have you calculate managed tack time, and if the cycle time is 190 seconds, can customer demand be met? So we first start out by calculating the time available. In this case, 2 shifts is going to be equal to 51,600 seconds. We're then going to subtract the changeover time for the shift, which is going to be equal to 60 minutes times 60 seconds. And we're going to subtract that, and we come out with 48,000 seconds. Now, in this case, customer demand is 5,000 pieces per month. So again, daily demand, we take 5,000 pieces per month divided by 20 days in a month, and we come up with 250 pieces per day. Our managed tack time is going to be the time available minus the expected lost time, and that was 48,000 seconds. And we divide that by our daily demand, which is 250 pieces, and we come up with 192 seconds. Our managed tack time of 192 seconds is greater than our cycle time of 190 seconds, so customer demand can be met. In our 4th example, we'll do another calculation of managed tack time. So in this case, the production cell now has 3 parts made in the cell, but it changes over 3 times a day to produce each of the parts every day. The changeover time for each changeover is 60 minutes. 2 shifts again with a 30-minute lunch, 2 10-minute breaks. So if we calculate managed tack time and the cycle time is 190 seconds, can customer demand be met? So in this case, same scenario, except we're going to do 3 changeovers a day versus 1 changeover. So in this example, our time available is going to be equal to the 2 shifts, which is 51,600 seconds, minus 3 changeovers times 60 minutes in an hour times 60 seconds in a minute. So 3 times 60 times 60 is equal to 10,800. We subtract that from the 51,600 seconds, and we come up with a time available of 40,800 seconds. Customer demand, again, 5,000 pieces per month, so our daily demand is 250 pieces per day. So our managed tack time is equal to 40,800 seconds divided by 250 pieces per day, which comes out to 163.2 seconds. We're going to round down, so we come up with 163 seconds. So our managed tack time of 163 seconds is less than cycle time of 190 seconds, so customer demand cannot be met. So from the two examples, example 3 and example 4, the only difference was we changed our number of changeovers we're doing per day. Example 3, we were doing 1 changeover today per day. Example 4, we're doing 3 changeovers per day. So you can see the impact that changeovers have on your actual tack time. And you can see why managed tack time in those cases is a good tool. So if you're going to have instances where you're going to have the same amount of time or expected time not available each day, that's a good example of where you want to use managed tack time versus just the typical tack time calculation.